1 out of 2 nitrogens in your body is derived from is actually derived directly from nitrogen that we produce through the Bohr for a nitrogen fixing process. That is, I believe, the Bohr-Haber process. And it's one of the most energy-intensive process that requires a couple hundred degrees Celsius temperature. It is done at super high atmospheric pressure. It is dangerous. It can lead to explosions and more. But 1 out of 2 nitrogens in your body comes from this process. Super bad process, and it requires expensive catalysts and metals, and we really haven't gone much better at it. Then we have a bunch of other fertilizer problems, in that fertilizers can lead to runoff, which can destroy habitats or the environment, and actually means you have to use more fertilizer as destroy the habitats. It can lead to lowered biodiversity, which affects pollinators. The excess ones that run off means you have to even make more for more energy intensive. It can slowly destroy the natural microbial system. And it might cause imbalances because you're feeding so much of one nutrient when you're not feeding as much of other nutrients. So, and then it just takes up land area. We have most of the land people live on. Most of the land people use is now used for farming and agricultural purposes, and we're running out of land. So is there a way of restoring the land that we get damaged and providing fertilizer without using up much new land? And I think there is a way. And I think we can do that with nitrogen fixing algae. We take these algae, we grow them out in the sea, and we harvest them, dry them up, and we use them as fertilizer. The advantage of this is A, we don't use up land area. B, not only do we not use up land area, these bacteria store nitrogen in more complex ways that give it off over time more, and giving it off over time more means that they can absorb the nutrients better. Because they can absorb the nutrients better, they'll get healthier, and also they introduce more organic stuff to the soil. Organic things are a lot better for bacteria in the ecosystem. They can also help restore the ability to absorb water, all these molecules. And they also give stuff that's already more simple than just the ammonia, which is this N with some hydrogens or N with some oxygens. They're much more assembled, so the plant actually has to work less to assemble into new forms that are useful for it, so the plant can devote more energy to growing. And also for bacteria, it also takes up more minerals from the ocean, and these minerals taking up are not bad necessarily. The reason why I say taking up minerals from the ocean are not bad necessarily is because the ocean has a ton of it, and as you take up a little bit, more of it dissolves from naturally all the time from rocks, even magma and lava, so it's not that bad. But we take it out from soil usually and run out. The other thing is, eventually these algae themselves can be sold because some people do eat them for food, and the algae can help prevent ocean acidification, take in a lot more CO2, and they work a lot more efficient than any land plant, by almost an order of magnitude. So I think this is a good thing to look at for the future. Well, thank you very much. Hope you found this interesting. Please like and subscribe. It really helps the channel out. Thank you very much. Goodbye.